Next, NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The golden record on Voyager One may have finally been decoded by aliens. Scientists say the solar system's farthest traveler, now 24 billion kilometers from home, is sending back signals that leave NASA trying to figure out just what it is saying. Is this just another technical glitch in the Voyager One, or is this our first contact with an alien civilization? Join us as we uncover the alarming message Voyager One received from a nearby object in space. Launch and historic achievements. In the blazing summer of 1977, while most Americans danced to the Bee Gees and lined up to see Star Wars, NASA was quietly preparing for its most daring mission ever. Two golden spacecraft, each about the size of a small bus, sparkled in the bright Florida sun at Cape Canaveral. These twin explorers, named Voyager One and Voyager Two, were set to embark on the longest road trip in human history. The excitement at NASA was palpable as engineers and scientists put the final touches on the Voyager spacecraft. Their sleek bodies gleamed with gold, not just for looks, but to protect their delicate instruments from the harsh conditions of space. Voyager 1 and Voyager 2 were outfitted with an array of cameras, spectrometers, and other scientific equipment, all designed to unravel the mysteries of our solar system. The original plan was simple: a quick 5-year dash past Jupiter and Saturn to take pictures and collect data. But these adventurous spacecraft had other ideas. Voyager 2 became the cosmic superstar. After gliding past Jupiter's swirling storms and Saturn's stunning rings, it sailed on to become the first spacecraft to visit the icy giants, Uranus and Neptune. The pictures it sent back left scientists in awe. Uranus's tilted rings in 1986 and Neptune's fierce dark storms in 1989 showed us worlds we had only dreamed about. Voyager 1 was on a mission for an even bigger prize. In August of 2012, this tireless explorer did something no human-made object had ever done before. It broke through the bubble of our solar system and entered interstellar space. Think of it as crossing from your backyard into a vast wilderness that no one has ever explored. Scientists were so amazed that they spent a whole year double-checking their data before announcing this groundbreaking news in 2013. These spacecraft carried something truly special: the most advanced technology of their time. Each Voyager had more computing power than the early home computers of the 1970s, along with instruments that could measure everything from magnetic fields to tiny particles in space. Most impressively, they were built tough, designed to handle temperatures cold enough to freeze nitrogen and radiation levels that could instantly destroy a smartphone. Their journey has revealed countless surprises. They discovered that Jupiter's moon Io has active volcanoes, the first we had ever seen beyond Earth. They spotted unknown rings around Jupiter, found strange spokes in Saturn's rings that shouldn't exist, and measured solar winds that no one even knew were there. The best part: these spacecraft were built when digital watches were cutting-edge technology, when most phones still had rotary dials, and when the internet was just a dream. Yet they're still going strong, still sending back data, and still teaching us new things about our cosmic neighborhood. Today, Voyager 1 leads the way as humanity's farthest-reaching creation, while its twin follows closely behind. Together, they've changed astronomy textbooks, solved ancient space mysteries, and opened our eyes to the true size and beauty of our solar system. They've traveled so far that their radio signals, moving at the speed of light, now take over 22 hours to reach Earth, and they're still on their journey. What began as a modest 5-year mission has turned into humanity's greatest space adventure, a journey of over 45 years that has forever changed how we see our place in the universe. Just when we thought the Voyager story couldn't get more incredible, NASA's tracking systems detected something extraordinary. Our tiny spacecraft had entered a region of space where even the laws of physics seemed different. Could this be the cosmic discovery we've been waiting for? Let us find out. Current status and records. A figure like 24 billion kilometers is too enormous to conceive of sensibly. To make it a little more understandable, we can think of going up into space in a car, But not in just any car. We're talking about highway speeds here. That's how you get to the 27,000 years to reach Voyager 1's present location. Once it got there, though, Voyager 1 didn't stop. If we could somehow pace it to the next landmark in space, the heliopause, where solar wind peters out and the local interstellar medium starts to take over, it would be well past our next big birthday to the tune of probably 160,000 years from now. Moving at an unbelievable pace, Voyager 1 serves as our sight and sound in a bizarre region known as Interstellar Space. Here, in what amounts to a solar system version of a cosmic graveyard, it is sending back data on stuff we never imagined was out there. The still-functioning Voyager 1 is sending back strange data, what the scientists are calling plasma tsunami waves, a curious form of cosmic rays that shouldn't exist, and unexplainable magnetic fields. As Voyager 1 moves farther away from our solar system and the planets within it, we are learning more about what lies beyond our heliosphere, about the very edge of the solar system and the interstellar medium. What surrounds Voyager 1 is not what we anticipated. Rather than being void, it is a melange of charged particles left over from stellar explosions that occurred millions of years ago. These particles convey narratives of violent and tumultuous cosmic events that we are only just beginning to comprehend. Voyager 1's most noteworthy find could be the one it made about our solar system. Backtracking from its current position, it is giving us a look at the heliosphere, a colossal bubble formed by the solar wind emitted by our sun. The spacecraft has demonstrated that this bubble is not a perfect sphere, but instead is squished and dented by the pressure of interstellar space. Its surface is an irregular, wavy sheet. It bulges slightly in the direction our solar system is traveling through the galaxy, and it dips down in the direction of the nearest star, Proxima Centauri. Its surface area is enormous, but we are only at one end of it. The next solar system is fairly close to us, but even so, it has 500 million years of history behind it. Even though Voyager 1 has been functioning for an incredibly long time, as long as many of its engineers have been alive, it doesn't show any signs of aging. Every second, it's moving another 17 kilometers into the wild unknown, deeper and deeper into the stuff of the great beyond, of cosmic human history. Every signal it sends back becomes somehow even more significant, a new milestone in the story of exploring the human frontier. Engineering and communication system? Ever wonder how a machine built in the 1970s, when most calculators couldn't even do square roots, is still working perfectly in the harshest environment known to humanity? The answer lies in some seriously clever engineering that made Voyager 1 the toughest spacecraft ever built. Let's start with power. While most spacecraft use solar panels, Voyager's engineers knew that wouldn't work in the darkness beyond Saturn. Instead, they gave it 3 nuclear batteries called RTGs. These amazing power plants use heat from decaying plutonium to create electricity, the same process that keeps Earth's core hot. Each RTG started with 470 watts of power, about enough to run 4 bright light bulbs. But Voyager 1's true genius shows in how it handles the brutal conditions of deep space. Its outer shell is wrapped in special gold-colored foil that reflects heat and radiation. Inside, it has 3 separate computers that can check each other's work. If one makes a mistake, the others catch it. That's more advanced than many planes flying today. The spacecraft's brain is incredibly efficient. It runs on just 64 kilobytes of memory, less than a single modern digital photo. Yet this tiny computer manages to control 11 different scientific instruments while constantly keeping its antenna pointed at Earth. It's like playing chess, solving math problems, and balancing on one foot, all at the same time. Speaking of instruments, each one is a masterpiece of engineering. The cosmic ray detector can spot single atoms zipping through space. The magnetometer is so sensitive, it could detect a refrigerator magnet from a mile away. The plasma sensor measures particles so thin that 1 billion of them would weigh less than a snowflake. The star of the show is Voyager's communication system. Its main antenna, nearly as wide as a tennis court, can catch radio signals so weak they have less energy than a falling snowflake. When these signals reach Earth, they're picked up by massive dishes in NASA's Deep Space Network, including one in California that's taller than a 20-story building. Every part of Voyager 1 was built to last. Its backup systems have backup systems. Its wiring is thick enough to survive micrometeorite hits. Even its computer code is written in a special way that lets it keep working, even if parts of its memory fail. The engineers who built it thought of everything, even including spare copies of crucial systems that could be switched on decades later. But perhaps the most impressive thing about Voyager 1's engineering is how it adapts to problems. When its primary thrusters began to wear out after 40 years, it simply switched to backup thrusters that hadn't been used since 1977. Today, Voyager 1 continues its journey, carrying on board the culmination of 1970s human ingenuity. Despite being decades old, Voyager 1 remains an emblem of human resilience and innovation. Its journey represents a time capsule of 1970s technology that has remarkably withstood the test of time. The spacecraft's ability to adapt to challenges and operate autonomously, especially given its distance of over 14 billion miles from Earth, demonstrates the foresight and precision of its engineers. Each design element, from the rugged power supply to the data-saving algorithms, showcases an understanding of both the constraints and potential of deep space exploration. Voyager 1's legacy also inspires future missions. It reminds us that sometimes simplicity and redundancy are key to durability. As it continues to transmit data from the outer edges of our solar system, Voyager symbolizes not only the power of human ambition, but also the boundless curiosity that drives us to explore the unknown. In its silent journey through space, it speaks volumes about our quest for discovery and the enduring spirit of exploration. While Voyager 1's sophisticated systems keep it functioning in the harsh void of space, it carries something far more precious than scientific instruments, a message meant for alien civilizations that could reshape humanity's place in the cosmos. But what exactly is this message? The golden record and alien contact. In the depths of interstellar space, Voyager 1 holds the most ambitious greeting card in the history of humankind, the golden record. Made of copper and gold, this 12-inch disc holds not just sounds, but carefully thought-out images that tell the story of our world. Its various messages are meant to convey something fundamental, not just about Earth, but about humanity itself. Earth's diversity is shown in 116 astounding visuals. These are not mere photographs, but astonishing representations, perhaps calls to the viewer to appreciate the miracle of life in all its forms. If Gary and the Curiosity team could only take one photograph to represent the mission, the contents of the book, or even what it means to be human, one could argue that it should be next to the depiction of DNA. Various cultures are represented in the music of the Golden Record, which includes classical works by greats like Bach and Mozart, as well as songs from long-time Australian Aboriginal groups in Central Australia. One of the record's most charming features, however, is its greeting in over 50 different languages, ranging from those used in the distant past like ancient Akkadian to languages spoken today like modern Japanese. The eminent astrophysicist Carl Sagan headed a small but dedicated team that selected the contents of this golden record. He and the team, comprised of artists, scientists, and cultural experts, spent much time deliberating over which discs would best represent Earth's diversity to an alien intelligence. If extraterrestrials come across Voyager 1, 3 different possibilities present themselves. 1, a sieve that is as advanced as we are, or more so, decodes the record and understands the music and the pictures. They might even like the pictures of Earth showing it in its pre-pollution state and our attempts at classic rock and jazz. If these entities can communicate across the stars, they might send a reply signal back to Earth's direction. The possibility of receiving such a signal has, of course, been prepared for by the National Aeronautics and Space Administration, which has several deep space listening posts scattered across the solar system. The third potentiality posits that extraterrestrials might adopt a hands-off approach, allowing Voyager 1 to serve as a kind of historical artifact. This would be in line with what some scientists propose as the zoo hypothesis, That is, they see advanced civilizations rarely contacting developing ones, and when they do, we imagine something like the hands-off approach that wildlife biologists take when studying the creatures in their natural habitats. NASA engineers took extreme care to ensure the longevity of the golden record. They coated it in uranium-238, a material with a half-life of 4.5 billion years, somewhat about the same age as the Earth. The team that designed the record also provided universal instructions for its use, diagramming the technique necessary to make the components of their space-age record player work. For these signs and symbols to be meaningful, the NASA team reasoned, the extraterrestrial intelligence that finds the record must possess an understanding of physics and chemistry similar to ours. Recent technical challenges. For almost 5 decades, Voyager One has sent orderly signals to NASA. They have interpreted these signals to mean the spacecraft was operating in an orderly manner, an attitude they're quite content with. However, in 2018, Voyager's internal compass, the AACS, started throwing out signals that suggested something wasn't quite right. Like an old-school radio astronomer who'd lost the ability to find the right kind of celestial body, the AACS had stopped pinpointing Voyager's position with any kind of accuracy. It was still doing its job of helping Voyager maintain a locked-on attitude, but it was imperfectly illuminating the situation, a bit like a flashlight that doesn't quite light up all the corners of a dark room. Scientists were mostly baffled because, despite all the confusion, Voyager One behaved as if it were in perfectly good health. Commands sent from Earth were received and executed, and valuable scientific data continued to be returned from the spacecraft's present condition of nearly 14.8 billion miles from Earth. Astronomers still had no clue as to what was going on, because the signal being returned indicated a problem with the AACS that should not have existed. The communication signal was strong. Suzanne Dodd, project manager for both Voyager spacecraft, said, "You're getting this nice formatted English message back from the spacecraft, and yet the message itself doesn't make any sense." NASA's engineering team faced a singular and tough predicament. Unlike troubleshooting a computer on Earth, restarting it is impossible. Voyager One was sending back less and less data with each passing day. Diagnostic commands, painstakingly crafted by NASA's engineers, were sent both ways, one way taking over 22 hours to reach the spacecraft and another 22 hours to come back again. After several days of deducing and inferring, the engineers discovered that the AACS was sending its data to a spacecraft-defunct computer, one that had gone non-operational some years prior. That computer had been the logic hub of the AACS, so the communication channel had been off for a long time. In a daring move, engineers told the AACS to send its data to the right computer instead. This wasn't as straightforward as it sounds. It took careful coding and timing, almost as if the commands had to be sent in a musical tempo to reach Voyager without causing more problems. They think a bad command from another computer on board Voyager misled the AACS in the first place, and that some other hard-to-detect issues might be present in the aging aboard system. The tenacity of Voyager One leaves astronomers awestruck, and rightly so. Here is a machine designed in the late 1970s, with parts engineered and built to the best standards of those times. And it has outlived most of its contemporaries, though almost none of its parts were intended to last this long. In September 2003, the craft entered its 46th year of operation, eclipsed only by the 60th anniversary of Pioneer 6, on which many of Voyager's parts were based. The craft began experiencing power shortages for its science instruments in 2021, and engineers at JPL have worked hard since then to keep the signal alive and to keep re-establishing the connection with the craft whenever it winks out. While NASA engineers solved Voyager One's puzzling behavior, there is a more pressing challenge: to keep this distant explorer alive and talking. At 14.8 billion miles from Earth, how does this aging spacecraft maintain its vital link to home? Power and communication details. Voyager One's communication system relies on a magnificent dish antenna. Unlike the tiny ones used by home satellite systems, Voyager One's dish is over 1 meter wide. Its size gives it sensitivity. Its carefully controlled shape makes it a highly directional antenna. In fact, if the high-gain antenna could be aimed at a target on Earth, it could cover an area approximately half the size of the state of Pennsylvania. The Voyager 1 spacecraft sends messages to Earth using two different radio frequencies, 2.3 GHz and 8.4 GHz. When Voyager 1 receives a message back from Earth, it requires that message to be sent at a slightly lower frequency, 2.1 GHz. These frequencies work extraordinarily well in the vacuum of space. They are fine-tuned to be even better than the good old space radio that the Apollo astronauts used. The signals transmitted by the spacecraft start out as a puny 20-watt emission, the same as a typical light bulb found in a refrigerator. When these signals reach our planet, they have transformed into the most undeserving of waves, far less energetic than a whisper in a quiet room. But NASA's large, 230-foot-wide missiles of dishes are still able to eavesdrop on what is practically nonsense coming from the Voyager spacecraft. To cover the enormous gap, Voyager 1 carries a digital tape recorder that has a capacity of around 67 megabytes. That would be enough to hold about 15 songs on a typical phone. But music can't really help us understand who we are and where we come from, unless you play the kind of music that's on the golden record. Voyager 1's still functioning and still sending back data from over 13 billion miles, making it likely the most remote tape player in existence. It takes over 22 hours for each signal from Voyager 1 to reach Earth, long enough to traverse the world twice. In comparison, the Mars rovers can ping Earth and get a response back in a brisk 15 minutes. Every communication with Voyager 1 is a feat of patience and precise timing, necessary for the kind of simple interactions that keep this farthest from home spacecraft in touch with the people who built it. This cosmic chat relies on NASA's Deep Space Network. The network has within it what might be considered the two best ears in the solar system. These ears are made of antennas. The antennas are of two types. One type is the 230-foot diameter antenna, and the other is the 112-foot diameter antenna. The two types of antennas together are sensitive enough to detect signals 1,000 times weaker than what a person could hear with a local FM radio station. Modern technology has made these detectors so sensitive that they could, in principle, pick up signals from space probes situated many light years away. The big question is whether they could do so if the signals were not somehow boosted to an energy level many times greater than that of the signals we now get from Voyager 1 and 2. Maintaining the link between Voyager 1 and Earth calls for astute control of power. The spacecraft generates its electrical energy with the help of nuclear batteries called radioisotope thermoelectric generators. These power sources lose power with time, but unlike an ordinary battery that eventually gives up the ghost and stops functioning, an RTG just keeps on going until it runs out of usable power, similar to how an ordinary flashlight dims before it gives up. At the time of its launch, Voyager 1 had a power supply of 470 watts, enough to energize 4 incandescent light bulbs to their full glow. Today, even with decreasing sunlight, the spacecraft operates on less than 300 watts. Yet even that figure is misleading, for the heaters that keep some of Voyager's tenuous circuitry in working order use power that, when added to what the working instruments themselves require, comes dangerously close to the 300-watt ceiling. Power management is job one for the command team. Even with these attempts to conserve energy, the supply on Voyager 1 continues to decline at a rate of about 4 watts per year. This steady drop forces the mission's engineers to keep coming up with new ways to boost what's left of the power and, most importantly, to maintain the connection with Earth. Final mission timeline. The epic adventure of Voyager 1 is coming to an end after 46 years of space travel. This incredible probe has covered over 14.8 billion miles and has pushed the frontier of human exploration further than any other object in history. But now its power reserves are on life support. When the last of its handful of science instruments goes quiet, there will be no more chatter from Voyager. In 1990, engineers at NASA made the tough call to turn off Voyager 1's camera after it had taken its now iconic pale blue dot picture. In that photo, Earth is a mere speck, a tiny blue dot in the unfathomable darkness of space. It was clear to everyone that the image was historic. Subsequent studies have shown that the Voyager One camera might have been able to do a little more, but at this point, there's really nothing left to do with the camera, and it is using an unnecessary amount of power. So, the choice became fairly obvious. The last years of the mission will play out like a carefully orchestrated farewell dance. From 2025 to 2026, the remaining scientific instruments will gradually stop working. Power levels have dropped too low. They can no longer be kept running. Some instruments might last until the end of this decade, sending their last messages back from the cosmic frontier. The ultimate goodbye might happen in the mid-2030s. Due to a variety of technical factors, the team estimates that 2036 is the most likely year for the Voyager One to send back its last transmission. Once Voyager One falls silent, its expedition will not have reached an end. The probe will press on through the Milky Way, with the Golden Record as a time capsule of Earth. In approximately 40,000 years, it will swing past a star in Ursa Minor, a star named AC plus 79,388, which is about 1.6 light-years from the spacecraft's current location. Voyager's power supply will continue to light up the Golden Record for another 5 billion years or so. Long after it has stopped communicating with Earth, the spacecraft will still be sending out a signal that can be detected with today's radio telescopes. Prior to the cessation of communication, scientists aspire to painstakingly collate vital data regarding the solar boundary, the region where our sun's reach peters out and interstellar space begins. The sun commands a huge area called the solar system, which dwarfs the boundary region. What happens at this unexplored area, as one of the lead scientists on the project has dubbed it, is crucial for gaining some sort of grasp on the solar system giant's domain. As Voyager One nears the end of its legendary mission, the future of its twin, Voyager 2, teeters on a knife's edge. An unexpected glitch has silenced it, leaving NASA waiting in suspense. Will contact ever be restored? Voyager 2 current update. The spacecraft Voyager 2 has journeyed well past most other missions in terms of distance achieved. It is now the second farthest human-made object from Earth, at an astounding nearly 20 billion kilometers. The mission, which launched in 1977, has afforded us some of the outer solar system's most spectacular sights and a wealth of data about the Sun's most distant planets and their moons. Most of that data and many of those images came in a series of remarkable close-up flybys of outer planets, with the spacecraft still sending back information from its last close-up of Neptune in 1998. Yet a simple command to an onboard computer to switch to an auxiliary power system signals a problem that a team working with the spacecraft never anticipated. At the end of 2023, a slight operational error shifted Voyager 2's antenna by 2 degrees. Although this is a small change in human terms, in the vastness of space, it is more than enough to sever the link between the spacecraft and Earth. For weeks now, NASA's powerful tracking system in the Deep Space Network has failed to hear signals from Voyager 2. Despite the impressive tech and antenna arrays of the Deep Space Network, particularly a massive 70-meter-wide dish in Canberra, Australia, the spacecraft is talking to no one. Diligently, Voyager 2 has been relaying information from the region beyond our solar system. It has been measuring cosmic rays, magnetic fields, and solar winds, phenomena that, when understood, will illuminate the structure and behavior of the universe. On October 9, however, a serious problem developed with the spacecraft's communication system. When hope is dim, one looks for any sign that conditions might improve. NASA engineers are reasonably assured that Voyager 2 has not succumbed to being lost. The deep spacecraft, still operational after 46 years, was hoped to still be working before it set an expected reset on October 15. While NASA hopes for a resetting of the Voyager 2, the world looks on with breathless anticipation. Can the old craft, now the second oldest of the American space program, find its voice again? Thanks for watching. Make sure to like our video, leave a comment, and subscribe to the channel. Also, check out another of our interesting content by clicking on the video showing on your screen right now.